Swayam Prabha. Digital India. Educated India.
So what drove somebody to say, I prefer paging rather than? Can you guess? I'll give you 2 minutes. Can you come out with an answer? Why should say, for example, Linux talk about ensuring protection through paging rather than segmentation? Well, simple reason. What could be a simple reason? Most obvious.
Because paging is dynamically allocated memory.
Segmentation also dynamically you can add. As a OS designer, right? Look at from a OS designer point of view.
Is more control.
Segmentation is more controlled. See, the essential thing, as a OS designer, what will you do? So you want to start a OS group. See, you don't want to bind yourself to an architecture, correct? Correct? Yes or no? You don't want to really kill yourself with respect to an architecture. When I write an operating system, it should work on processor A, processor B, processor C, processor D. You can't write one operating system for each one of these processors. Correct? Are you able to get what I am trying to say? Right? So that is perhaps one of the major reasons why if you look at segmentation versus paging, and if you finish your 4th assignment, after you finish your 4th assignment, you will realize that paging is much more generic than the segmentation. See that segmentation here, that 64 bits that you have assigned, some 16 bits are here, some 3 bits are there, some 2 bits are here. It is like, like if you take a cockroach, put it in ink and put it on a paper, white paper, no, the way it will go and scratch it, like that things are distributed, right? That's the easiest analogy I could get, correct? Right? There's no rational. If you ask me why this, for a limit bit, some 16 is there, some 4 is somewhere in the middle, okay? So, absolute thing. Why these things? If you ask these why questions, we don't know. We don't have an answer much more than it, but probably there may be something more. Okay, now, but when you look at that and this, right, at least you should do your 4th assignment. After that, you will appreciate that paging is much more generic than this. So if I want to take this operating system and put it on to say Spark or into IBM Power X or anything, I want to move it to the next, architecture, Power or Spark and whatever, or ARM, right? If I am going to invest my time on paging, then for me to go and do that paging, say everything has a multi-level page walk. So for me to go and switch this operating system for, the next architecture, I will be more happy to play with the paging. The effort would be much less if I depend upon the paging mechanism rather than the segmentation mechanism. Right? Segmentation will go mad. You have to rewrite the entire operating system. Well, after all, what is the operating system? The major thing there is memory management. Right? Process management is trash. Okay, so it's not that great. The entire whole thing is memory management, because everywhere as I told you, right from execution of an instruction, there are 5 stages, 3 stages touch memory. When I want to start execution of an instruction, when I want to start the process, I have to allocate memory. And when I look at protection, what is protection? You should not read my memory. Okay, it's not that you should not use the CPU or anything. You can share everything else in that life. Your general purpose registers can be shared. Your CPU can be shared, ALU can be shared, bus can be shared, peripherals can be shared. One thing you cannot share is memory. Right? The whole operating system is basically governed by memory. Today, the whole problem of information security comes because we have memory issues. Because there is some loophole in memory management. Right? Are you able to appreciate these facts? Right? So that is the strength of an operating system basically comes from how effectively they could handle memory. And so when I have invested so much time on developing an operating system for an architecture and I want to move to a next level architecture, the major thorn in that flesh would be memory management. And that I want to safeguard. So when we look at segmentation as a memory management principle versus paging as a memory management principle in the context of x86, we find that paging is more generic than segmentation. That is why we would like to invest more time on paging. Okay? So before we wind up today, let me just cover one more topic, and then when a process comes to execution, now I give it, say, I am an operating system, how many pages should I allocate for? So when I compile, right, I know the size of the code and all. I know the size of data, everything. So I will allocate that many pages as much as that many data is there. Okay, so, right? So that page allocation will happen in the virtual address space. Now, what will happen is, when I want to execute, I am doing demand paging, right? So I have to move the pages from the virtual address space to the RAM. In the RAM, suppose as a program, I need 5 pages of code and 6 pages of data, right? I can't allocate 5 and 6 there. Then that means your virtual address and effective address and physical address become same. So I will allocate some amount of pages, right? I will say, okay, have say k pages for code, k page frames for code, some r page frames for data. You need some 10 pages, your code spawns across 10 pages. I cannot give you 10 pages in the main memory, right? I will only give you, say, 2 or 3 pages. So you use these 2 or 3 pages in the main memory and keep moving your page frames there, here and there, and then try and execute it. Okay? So as a process P1, my code spawns across, say, 10 pages of code, 5 pages of data, actually 15 pages of data, 3 pages of stack. This is my full requirement. But in that thing, I will go and say, this is your size, so okay, I will give you 4 pages of code, some 6 pages of data, and say 1 page of or 2 pages of stack. You use these 12 pages and execute this 28 page program. So that means as and when you will keep replacing pages, you will take page and 2, right? So the number of actual page frames allocated for your program, you have to use those page frames and keep shifting your pages in and out to see that your program goes to execute. This is right? So as a process, I will need so many pages. As an operating system, I will give you so many page frames. Use these page frames to execute your program. The number of page frames that I am allocating may be proportional to the number of pages actually you require. Sometimes it is. Okay. So there's again hundreds of papers written, and 50s of students who have got PhD and tens of professors who have got tenure track by this. Okay, to study this relationship. Okay, but the thing is very, very simple, right? To understand this as a concept, it is just I am giving you k frames. This is a k frames is your requirement. K pages are your requirement. Some r frames are given. Use these r frames to execute that k page program. Now I will just ask one question and stop here. Why should I give 2 pages at least, say, for data or instruction? Why should I give 2 pages at least? If I just give 1 page, what would be the problem? I am giving 1 page, so use that page for code. 1 page for code, 1 page for data, 1 page for stack.
Supposing you want to perform an operation and whatever operation required
for my page directory.
Huh?
I lose 1 page for my page directory.
That's okay. That's okay. 1 page directory and 1. 4 pages I give you. 1 page directory, 1 for code, 1 for data, 1 for stack. Yes? Question?
If you had two different operands and you needed, then if they were in 2 different pages, then you certainly need them.
Two different operands, okay? A very simple thing. Let me say I am accessing say EAX comma some address, right? Move, right? So suppose so this 2 bytes of, so this is a 32 bit, right? 4 byte. Let me assume 2 bytes are in this page and the remaining 2 bytes are in this page, and this is the page boundary, okay? Now I have allocated only one page for data, so I will be loading this, and when I start executing this command, what will happen? It will get the 2 bytes, the remaining 2 bytes will say page fault, sir. Once I get a page fault, what I do, I go to the page fault handler, I have got only one page for data, so I will go and load this and start re-executing this instruction. Then say, sir, page fault again. So I will go, so I will be just ping-ponging, one page will come here, again it will go, another page will come, this move will never complete. Okay, this is a very, very simple, obvious reason why I have to allocate at least 2 pages. If I don't allocate 2 pages, then what will happen? I will have these 4 bytes, 2 bytes on one page and exactly on that boundary, or 3 bytes there, 1 byte here, or 1 byte there and 3 bytes, just spawn it across. So when I try to access that, one data page will be there, correct? I will get that data page. Now I will find only 1 byte is there, remaining 3 bytes. There is no provision of keeping 1 byte and saying, okay, come next. So I will just cancel that instruction, because that instruction has cost me the granularity is one instruction there. This instruction has cost me a page fault. Okay, suspend that instruction, store that PC. Now I will go and execute the page fault handler. Again come and start that instruction again. Then it will find out that again 3 pages are missing, right? So that is perhaps another reason why there is something called alignment check. AC flag. If you go and look at your E flags register, there is something called an alignment check flag. Alignment check essentially says that you have to align all your 4 byte access on 4 byte boundaries. Okay, so this basically will not allow you, to have something in a 2. So this will happen if this particular variable starts at a 2 byte boundary, right? Right, this is because this is 0 to 4095. So if I have a 4 byte variable starting with 2 bytes here or 3 bytes here, 1 byte here, it is not actually starting on a 4 byte boundary. So when you are compiling, when you are compiling and executing for the first time, you put this alignment check flag to check where and all these type of violations are happening, and you go and take care of that violation. Essentially you put some dummy bytes inside to see that all these are aligned properly. If they are aligned, then this type of an issue will not come. Okay. So alignment check flag I will also talk in the context of memory management little later, but this is very, very important. I think I talked about alignment check in the third semester course also, but we'll cover a little more on that. Okay.